Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, I am going to describe pyridine structure and aromaticity. You know, pyridine is a six-membered heterocyclic compound with molecular formula of C6H5N, and it is obtained from coal tar. Another important point related to pyridine is it may be formally derived from the structure of benzene through the exchange of one ring carbon for a sp2 hybridized nitrogen. You know, my friend, pyridine is an aromatic compound. However, the nitrogen lone pair of electron is in sp2 orbital orthogonal to the p orbitals of the ring. Therefore, it is not involved in maintaining aromaticity, but it is available to react with proton. Thus pyridine is basic. You can see the structure of pyridine, nitrogens, and in proximity alpha, beta, and gamma. So 2 alpha position, 2 beta position, and 1 gamma positions. Now you can see here the orbital structure of pyridine. This is p orbital, and these electrons are in sp2 orbital perpendicular to the p orbital. Now I am going to show you some resonating structure. You know, pyridine can be represented as a resonance hybrid of the following structure. You can see here many resonating structure possible. Due to greater electronegativity of nitrogen relative to carbon, it tends to withdraw the electrons density from carbon atoms at position 2, 4 and 6, which therefore acquire partial positive charges, while the N atom acquires partial negative charge, while the carbons at position 3 and 5 remain neutral. Now, synthesis of pyridine, commonly strategy 5 plus 1. From 1,5-dicarbonyl compound. You can see here the derivative of 1,5-dicarbonyl compound undergo reactions with ammonia, dehydration occurs, further oxidation, then substituted pyridine obtained. Another example here, also 1,5-dicarbonyl compound, ammonium acetate, it gives the pyridine. Now, Bonneman's cyclizations. From acetylene to molecular acetylene and hydrogen cyanide, it passes through a hot tube. Pyridine is obtained. Hansch synthesis. This is also very important synthesis of pyridine. It is starting from methyl acetate beta carbonyl compound and formaldehyde. Dihydropyridine derivative obtained initially, then further undergo reaction with nitric acid, and it gives this product, which is further react with the KOH and calcium oxide under heat conditions. Substituted pyridine is obtained. Now, fourth method of synthesis of pyridine from pyrrole. You know, pyrrole undergo reaction with the chloroform in basic conditions, ring expansion occurs, and 3-chloropyridine obtained. Now, you can see the famous reaction Diels-Alder reactions. From Diels-Alder reactions also you can synthesize pyridine from 1,3-butadiene. Now, basicity of pyridine. You know, my friend, pyridine is a weak base. Since lone pair is an sp2 hybridizorbital is the conjugate acid aromatic. You can see in this reaction scheme, pyridine react with acid proton and forming pyridinium salt, pyridinium salt, and pKa value 5.2. It undergo many reactions typical of amines such as reaction with Bronsted acid such as chromic acid and hydrobromic acid. Compared to pyrrole, pyridine is much stronger base. This is due to the nitrogen lone pair is not involved in maintaining the aromaticity. Thus, it free for protonations. However, in pyrrole, the lone pair on the nitrogen atom is already involved in the aromatic array of p electrons. Protonations of pyrrole on nitrogen atom results in loss of aromaticity and is therefore unfavorable. So, you can see in this scheme how aromatic compound converted into non-aromatic compound. Compared to aromatic compound, compared to imidazole, pyridine is less basic. This is due to on protonation, the positive charge can be localized over two nitrogen atoms, while in the case of pyridine, it is delocalized over the ring which interrupt aromaticity. So, compared to imidazole, pyridine is less basic. Compared to pyrrole, pyridine is much stronger base. Now, compared to analogous aliphatic amines, pyridine is less basic. Aliphatic amines, you can see in this order. Why this is happen? This is due to the nitrogen atom in pyridine is sp2 hybridized, more electronegative, and the lone pair of electrons occupy an sp2 orbitals. Thus, it is held more tightly by the nucleus than the lone pair of electrons in aliphatic amines with sp3 hybridized nitrogen atom, and lone pair of electrons occupies an sp3 orbitals, less electronegative. So, this is the order, decreasing order of the basicity. Now, the negative pole in pyridine ring is at nitrogen, while the positive pole is at the carbon scale, which is opposite to that happen in the pyrrole. So, this is due to the greater electronegativity of nitrogen relative to carbon. It tends to withdraw the electrons density from carbon atom at position 2, 4 and 6, which therefore requires partial positive charge, while the nitrogen atom acquires partial negative charge, and the carbon at the position 3 and 5 beta position remain neutral. Therefore, these positions are the most preferred for the electrophilic attack. You can see here inductive effects and their resonating structure. Now, as a consequence of electron deficiency on pyridine ring, pyridine is less reactive toward the electrophile than pyrrole and benzene. It is resembles highly deactivated benzene derivative, where it doesn't undergo Friedel-Graf alkylation or acylations or coupling with the diazonium salt. Moreover, electrophilic substitution reaction of pyridine requires very harsh reaction conditions, high temperature to take place and are low yield. So, it is very important point to note it down. Pyridine is less reactive toward electrophiles than pyrrole. So, formation of monobromo and dibromopyridine, formation of nitropyridine, and formation of benzene pyridine sulfonic acid. Now, As a tertiary amine, pyridine has nucleophilic properties, thus it reacts with electrophiles. You can see the pyridine undergo reactions at room temperature and forming pyridine N oxide. Here react with HCl pyridinium chloride and N-methyl pyridinium iodide with the methyl iodide. So pyridine is very reactive toward nucleophiles than benzene. It resembles benzene having a strong electron withdrawing group due to withdrawing effect of the electronegative nitrogen atom. This is also very important point. As appeared from the canonical structure of pyridine, position 2, 4 and 6 carry partial positive charge. Thus, electrophilic and nucleophilic substitution proceed readily at the 2 position followed by 4 position but not at the 3 position. Additionally, attack at position 2, 4 or 6 results in the resonance structure in which the negative charge is delocalized at nitrogen. Thus, it is more preferred, while the attack at position 3 or 5 results in the resonance structure in which the negative charge is delocalized over carbon only. You can see the positive charge situations. So, orientation of nucleophilic substitution in pyridine, you can see the negative charge on nitrogens, negative charge on nitrogens, negative charge on carbon only. So, nucleophilic substitution reaction, the Chichi-Bevin reactions, you can see it react with NaNH2 ammonia under heating condition, substitute pyridine obtained. Same reaction with the organometallic compound lithium reagents. You can see butyl lithium react with the pyridine forming 2-butyl pyridine. So reaction with the potassium hydroxide, you can see pyridine undergo reaction with the KOH forming 2-hydroxypyridine, which undergo ketoenol tautomerism, give 2-pyridone. So reduction reaction, you can see pyridine undergo different types of reductions. In presence of lithium aluminum hydride, 1,2-dihydropyridine. In presence of sodium and ammonia, which is known as Birk reductions, it gave 1,4-dihydropyridine. It undergo hydrogenation, catalytic hydrogenation, it gave piperidine. It undergo high temperature and reacts with HI, forming the open structure like pentane. Now, derivative of pyridine, N-oxide pyridine. Pyridine can be oxidized easily to N-oxide pyridine by peracid at room temperature. On the basis of dipole moment studies, N-oxide pyridine is considered as a resonance hybrid of the following structure. So you can see the negative charge appears at the position 2, 4, thus active towards the electrophiles. Then positive charge appears at position 2, 4, thus active towards the nucleophile. So N-oxide pyridine, my friend, as appeared from the previous canonical form. There are positive and negative charge at position 2 and 4. The N-oxide pyridine is more activated for electrophilic and nucleophilic attack at this position than pyridine itself. N-oxide pyridine are very important intermediate for preparing pyridine derivatives that are difficult to appear due to the easiness of the removal of the oxygen atom by the reductions. For instance, nitrogen of pyridine is very difficult and low yielding reaction and it occurs at position 3. However, using N-oxide pyridine will direct the nitrogen to position 4 and then the oxygens can be easily removed by the reduction as shown in the following scheme. You can see pyridine undergo reaction with peroxide, it gave N-oxide, undergo nitrations, it gave 4 position nitro groups and PCl3, it gave 4-nitropyridine. The same 4-aminopyridine and these two products, 2-chloro and 4-chloro, and here 6% 3-nitropyridine. So I hope this video will be helpful to you. If you like this type of video, then subscribe my channel, and thanks for watching.